So they approached us and said, look, this is the idea we've got for the building, 22 pens, operating theatre, post-mortem room, pens for bigger animals that we're walking. How best do we protect it? Now on that process, one of the major problems that occurs in any quarantine centre is what we call transmutagenosis. This is where genes can transfer from one animal to another. It's one of the things we found with H1N1 and other such conditions, whereby we now know that these viruses can jump the gene pool. In that process, we then looked at it and we said, right, what we need to do is all the pens will be built around, if we imagine a U shape, then the main part of the U shape would then be all the pens, so they can get access from outside in. The inner part of the U shape would be then a feed corridor from door to door, and then within the inner part of the U would then be specialised holding pens. By creating then a positive air pressure into the U corridor, we could then bleed air from a positive pressure corridor into the pens. And by extracting through the pens, we could create and make the pens individually negatively pressured, which means winds blow high to low. So because you've got high pressure in the corridors, low pressure in the pens, nothing from the pens can get out into the corridor and be transferred from pen to pen. Okay, so we worked out how we needed to move the air. The next thing was, how we're going to clean it. The first thing we then realised was, has anybody checked the air quality of the air you're going to bring in the building? Because this quarantine centre sits next door to a zoo. With every animal in the world, from orangutans, apes, you name it, they've got it. So we then went on the roof of a building and took air samples. It was frightening. It was a good job at the time that the locale didn't understand exactly what was being emitted into the air. But of course, for a quarantine centre, it would cause mayhem. So that we then, when we designed the air handling unit as a conventional air handling unit, with the air inlet coming in, a standard, what we call a Euro 4 or G4 filter for the big bits, the birdie feathers and things, then through into a heating chilling system. One of the remits we were given was we had to maintain plus or minus 2 degrees in any of the pens at any one time. Now when you consider you could have a warm-blooded mammal or you could have a snake, it causes a bit of a problem, but we did it. And devised special heaters that would shutter into the system, and then special air conditioning, chilling systems that would cool it down during the summer. This was important because obviously this type generation would maintain a major saving in energy over what would normally happen, whereby you're just belting out, it's either too cold, you put heating mats in, or it's too hot, and then animals are getting very, very distressed, particularly birds. If they get too warm, they die. So we developed the air conditioning system that would give us the airflow. We put in then the closed couple field system as it was then, to pre-sterilise all the air, so we weren't going to be bothering about what was coming into the system. That air then was vented up onto the roof, and then that sterile air, and we actually did it in the air handling system, and we also did it as it entered the roof, so as a double whammy. We then put all that sterile air into the corridor areas, and we had stainless steel grills that bled that air back into each of the pens and rooms. What do we do with the extract air? We then had an extract vent on each of the roofs and built a closed couple field system into each extract vent, so whatever was in each individual pen could never even meet up in the ducting on the roof. So all the air was sterile once it left the pen and then went back into the system. It went back round, recirculated, was re-sterilised again. So I know it's a bit over the top, but this was quarantine, remember. And you have things like green cell disease in monkeys, what we call HIV. So you've got all sorts of things you've got to protect against. So we did that, and it's been recirculated around the system. Although our air quality was absolutely better than anybody had ever seen, DEFRA, our local government agency, had insisted on relying on a good old-fashioned HEPA coming in. Of course, the HEPAs were after our research system, so we were doing all the work. And as they normally went in at 0.6 inch water gauge and you change at 0.7 water gauge and you change them at 2.2, when they come to check these after year by year, they were running at 0.6. They were better than a clean set. So they then realised that these things are doing nothing but restrict airflow into the system. So they then, after 4 years, said, yes, you can take the HEPAs out. So we took the HEPAs out, and suddenly the airflows, of course, increased through the system. So we then had to back off the fans and whatever, which gave them further saving. something we'd not considered at the time, but hey, yeah, they didn't need as much air. You either could have a hell of a lot more air travelling around the system, or B, slow down the fans to have the same amount of air, and slowing the fans down, of course, reduces energy again. Now we have a situation where by 2009, that system had been granted a 3-world status, and there were only 3 or 4 3-world status quarantine centres in the world, so this was a tremendous kick for us. And Stephanie Sanderson, who's head of the zoo and whatever, goes around and really is fairly vocal about us everywhere she goes.